Again. Okay, so this is the worksheet mole to mole problems. We are going to first balance the equation, and then we're going to use this balanced equation to answer some of the questions here. Okay, so you have to balance each equation before solving, because we're actually going to pull information out of the balanced equation to help us answer the questions. Okay, so like we were just doing before, we identify the products, which are on the right side of the equation, and the reactants on the left side, and then look and see what elements we have. So we have nitrogen, and we have oxygen. Oxygen's in two places, but we just write down oxygen once. And then we have nitrogen and oxygen on the product side. Okie dokie. So now we count. There's one nitrogen here, and then there's one oxygen here, two oxygens there. So that's a total of 3 oxygens. And then on the product side, there's one nitrogen there, and then 2 oxygens. Okay, so nitrogens are fine, oxygens are not. So we need to figure how to balance. This one is a little bit tricky because we have oxygens in 2 different places. So, you know, like in my mind, my brain just went through a whole bunch of scenarios about what numbers I could put here. So there's no number that we can put that's gonna well, we have to put the numbers in the right places, is what I'm trying to say. So let's say, I'm just gonna say, well, let's increase the number of oxygens on this side to see what happens. So that's gonna give us 4 oxygens here, because 2 times 2 is 4. It's gonna mess with our nitrogens, but we can fix that, I think. All right, so can I get 4 oxygens on this side? Is there a number I could put here or here that when we add the oxygens here to the oxygens here, it adds up to 4? This one's a little bit tricky. So the answer is put a 2 here. Okay, so number 1, that's gonna balance our nitrogens, yay. But if we have 2 times 1 oxygen here, that gives us 2 oxygens here. And then this is O2, that's 2 oxygens there. So that gives us 4 oxygens. Trying to carry the adding of the oxygens on both of these can be a little bit tricksy. That's what makes oxygen sometimes the thing that trips us up, but that's the balanced equation. Put a 2 in front of the NO. O2 is just 1 molecule of O2, and then 2 NO2 molecules. Okay, so now it says here, we're gonna solve a problem. 2 moles of NO will react with how many moles of O2 to produce how many moles of NO2. So here's something that is new. So what this does for us, when we balance the equation and we have coefficients, it tells us the ratios of how many of each molecule is going to interact with how many of the other molecules. So this number 2 comes from here. So 2 moles of NO, and we know it's 2 moles because there, will react with how many moles of O2, whatever number is here. And there's not a number, but it's not 0. It's understood to be 1. Like in math, you don't say 1x, right? That's the same as x, so you just say x. All right, so there's 1 mole of O2, so we're gonna put 1 there, to produce how many moles of NO2, whatever this number is. So 2 moles of NO2. Okay, so when we balance an equation, right, once you get used to the language of chemistry, when you balance the equation, that's how you're reading it. It takes 2 moles of NO to interact with 1 mole of O2 to produce 2 moles of NO2. Okay, and then this is what that, if you write that out in English, that's what it says. Okay, so now we're gonna solve some problems. All right, so if we wanted to make, if we had 3.6 moles of O2, right? So we're given this. This is what we're given. All right, they told us this. How many moles, right? This is our question. how many moles of NO2 could we make? And this is something that a chemist would actually do in the lab. Make sure you take a packet. All right, so if I have 3.6 moles of O2, I want to make NO2. How much NO2 can I make? I don't know, I have to do the math. All right, so the way you do that is you say, okay, I'm given this number, whatever the measurement is, I'm gonna do a ratio. So just like we did dimensional analysis, conversions between moles and molecules, moles and atoms, moles and grams, we can do that mole to mole. Okay, and we just take this ratio, right? 2 moles of NO, 1 mole of O2, and 2 moles of NO2. Am I still in the thing? Okay. All right, so I'm gonna pull the number from here, right? 2 moles of NO2. I'm gonna write that number here. I'm getting that from up here. And how many moles of O2? There's no number here, so that would be 1. So I just write that there. So whatever the coefficients are, we can use that as a conversion factor to go mole to mole. So if we want to convert from moles of O2 to moles of NO2, we just put the conversion factor. For every 1 mole of O2, I can make 2 moles of NO2. All right, then I can cross out moles of O2 as a unit. Now if I do the math, right, 3.6 times 2, the answer is going to be in moles of NO2, which is where I want my answer. Okay, so I might be able to do that math in my head, but I don't trust myself. But now I don't know where my phone is. How did that happen? It's what?
The projector. On top of yeah.
You know what? You are correct. All right, so I need a vacation. Somehow I had a feeling you guys were going to find my phone. I just didn't know where it was. All right. Now I have to remember how to use a calculator. And this one's being all funny. It's literally giving me the alphabet. All right. There we go. Numbers. Right? Okay, clear. Can't see. There you go. All right, so if we have 3.6 times 2, 3.6 times 2 divided by 1 is 7.2 moles of NO2. That's our answer. Okay, so if we're going from mole to mole, then we're just using the coefficients as conversion factors. So we could say 2 NOs to 1 O2, 2 NOs to 2 NO2s, right? We can put them in any order we want to. And how do we know what order to put them in? You put the unit that you want on the bottom, the unit that you want to get rid of on the bottom. So the unit you want to get rid of, this unit here on the bottom, the unit you want your answer in on the top. Okay, so how do we do this one? How many moles of NO must react to form 4.6 moles of NO2? So let's say I'm in a chemistry lab. I want to make 4.67 moles of NO2. I need to figure out, do I have enough moles of NO to make this happen? All right, so I'm gonna take my measurement, right? Take my measurement and I'm gonna start there. They told me I need to make 4.67. Can we see this? No. Let's put this in a place you can see it. All right, good enough. All right, so you take whatever they tell you is the measurement. That's how much I need to make. So yes, sir, yes, ma'am, I am gonna try to make that. But I need to figure out how many moles of NO I need. NO2. Okay, I want my answer in moles of NO. And you can't see that. not on the big screen. I'm gonna back it up a little bit. Back it up more. Nope. I'm gonna move this just a little bit. Okay. So how do I get from here to here? I'm gonna do that conversion. I wanna get rid of this unit because I want my unit in moles of NO, right? Moles of NO. And I'm gonna put that on the bottom, moles of NO. And I want the moles of NO2. This unit I'm gonna put on the bottom, that's what I wanna get rid of. The unit that I want is on top. The fact that they're both NO something is throwing me off. Okay, so if I want to cross this out, I need to put numbers here that are accurate, what do you call them, ratios. So I'm gonna go back up to the equation and back up to this part A. Move this down a little bit. Right, where it says 2 moles of NO will react with 1 mole of O2 to produce 2 moles of NO2. Right, I'm gonna use that in our problem down here. Okay, so 2 moles of NO will react with 1 mole of O2 to produce 2 moles of NO2. So it's a 2-to-2 ratio that I'm pulling from the coefficients off the balanced equation. What's cool about this is not only can I cross out the moles of NO2, but what's 2 over 2? What's 2 divided by 2? 1. They cancel too. So it's just 4.67 moles of NO. I can do that math in my head. And that's it.